Okay, what we're going to do now is we're going to look at the standard normal curve in a little bit different viewpoint. We're going to view it as a probability distribution instead of area under a curve, that's what it is. This is a probability distribution. Yep. The sum of all the areas add up to 1, or all the probabilities add up to 1. Each individual probability is between 0 and 1. So that is a probability distribution, and that's how I've written it. What is the probability of getting a z-score greater than negative 1.04? So just like we did with area under the curve, I drew a plot, standard normal plot. I marked negative 1.04, approximately where it would be. And then I want the z-values less than that. This looks just like find the area to the left, like we did in part 1 of the standard normal distribution. Now, if we look this up, and I have done that already, please do it yourself to verify I'm not putting a wrong number up. I found that area right there. Hopefully you find the same. Now, if we look at this one, here I drew a standard normal curve, just like I did in all the other problems, and I marked approximately where 1.96 would be. And I'm looking for the z-values bigger than that. All the z-values bigger than it are over here. That's just like finding the area to the right of 1.96. Very much like we did in part 1 of the standard normal distribution. So if we look this one up, we get 0.9750. That gives us what area? The area to the left. That table always gives us the area to the left. So how do we find the black area? You subtract from 1. And this is a nice number here, 0.250. That's a nice number to work with. Now, if we look at the third problem up here, we've got between minus 1.4 and 1.4. Now, one thing I want to add that I didn't say last time is usually when you're doing an in-between problem, you got the same number on the left as you have on the right. Just the sign difference is the only difference. Why? You want plus or minus the same amount. You don't want plus 3 minus 2. You want plus or minus, like in a poll where you're doing polls, plus or minus 3%. You don't want plus or minus 5% on one side and 1% on the other. You want the middle. So usually these numbers match. You'll find in the textbook they don't do that. They're trying to make sure you can handle anything. Now, let's look at this. We want the z-values that are bigger than this and smaller than this. That's an in-between. Find the area in between those two numbers. So here we look at 1.4, and that gives us this number here, 0.9192. And that gives us the area all the way from here, all the way over here. Now we look at negative 1.4, that gives us 0.0808. That gives us the area from here over here. So how do we get the area between those two? We take the whole area, then subtract that away, and we'll be left with the shaded area. So we do a subtraction right here, 8384, and that's what you'll get. So you see, this is very much like finding the area under the curve, only it uses different symbology. Now, one thing else I'd like to say, what if I did this? Now I'm including 1.96. Earlier, I was not including 1.96. What happens? Well, this is area under the curve. Maybe I should have done this with the other lesson. But what is the area of the line? Let me see. The area of a rectangle, space times the height, or the width times the height. The line has no width. The area is 0. There is no area. This is still the right answer. It does not matter what I could put equal signs on all of these. It would not change any of those answers. So if I were to ask you a question like this, z equal to 2, what would your answer be? What's the probability z equals 2? Well, 2 will be about right there. What is the area of that line? Probability of that is 0. There is no area. Some people may say, well, 2 can really exist. There are ways to approximate 2 if you want to do it. But for this course, the equals has no area. So ignore that. Now, one thing I haven't shown you is the following. What if we have something like as follows? Probability that Z is greater than 4.2. What if we had something like that? Okay, let's draw what that looks like. Okay, and I don't need this here anymore. Greater than 4.2. So get your table out here and find 4.2. Please find 4.2. The biggest number on here is 3.69. So what do? 3.69. If this table ends at 3.69, then 4.2 is somewhere out here, isn't it? 4.2 is way out there. Well, think about it. If you're way out here, how much of the table is to the left of you? This is a cumulative table. I have not said that, but if you look, it starts with an area of 0. When you get to the middle, it's at 0.5. Then the other side goes from 0.5 to 0.99949. What is to the left of a number that's off the table? What is the area to everything? So probability, or if you want to say it another way, that is 1 minus, we subtract out the area to the left, which is nothing down here. 100% of the area is to the left of 4.2. 4.2 is a really big number. It's not on the table. What I want you to do, whenever you're working a problem, and the book does have a few where you get a number that's bigger than the 3.69 or less than negative 3.69, that takes you off the table on the small side. Use 0 when you're off the table on the left, and use 1 when you're off the table on the right. That's one thing I want you to do. Just work the problems as normal, but when you see a number that's not on the table, if the number is to the left of the table, use 0. If it's to the right, use 1. And that's how we use the standard normal curve. That's how we use it.